Okay, so we're just going to continue our work with what we did on day one when we talked about angle, angle, side, and side similarity. Okay, so remember, angles are always congruent, sides are always similar. I'm sorry, proportional in similar triangles. So if you look, I'm going to do these first two problems, and then the rest are going to be for you guys to do. Um, and it'll be more the same. You guys just really pay attention to reading, think about what I'm asking for. Um, Remember, just because there's a lot going on doesn't mean the problem is difficult. Time doesn't mean difficult. Okay, it just means it might take you a little time. Okay, for number one, it says find the value of x and the length of WC. Well, the first thing you need to know is that they're similar. So if you noticed, angle W and angle L are congruent to each other, and then based off of vertical angles, we can say that these angles in the middle, WIO and LIC, are also congruent to each other. So these are congruent by angle, angle, and even though it doesn't ask you to specify that, I always make sure. Okay, and they want us to find the value of x and the length of WC. We made this problem. Okay, so I always write a similarity statement. It helps guide my thinking. So triangle WIO is similar to triangle W is the same as L, I is the same as I, and O is the same as C. So I use, my system of circles, stars, underlines, whatever. So WI is the same as LI, and this is IO, which is the same as IC. So when you set up this proportion, remember there's two ways you can do that. I always do like a pair equals a pair, so x over 5 equals 4 over x. So remember, you can also do triangle equals triangle, in which case you would have x over 4 equals 5 over x. That's fine, whatever works for you. So when you cross multiply here, you get x times x, which we know is x squared, which should excite everybody because that means we're back to quadratics. And 4 times 5, which is 20. Okay, now remember, when you square root both sides to solve for this, you can't forget that there is a plus or minus. So this is x equals plus or minus the square root of 20. But remember, we always want to try and, a couple things. We always want to try and remember to um, reduce our radicals, as well as you want to check and make sure, does your answer make sense in the context of the problem? So first thing I'm going to address is this plus or minus. Mathematically, you need it here. However, it wouldn't make sense to have an x value that's negative because you're not going to have a negative length. So that means really the only x that's going to make sense is a positive square root of 20. So from there, we know that positive square root of 20 is just the square root of 4 times 5. So the 4 comes out as a 2, and the 5 stays underneath. So your x value is 2 radical 5. Okay, now let's see, it's WC. Okay, so from W to C is from here to here. Well, that's x and x. So technically, to find WC, it's x plus x. Sorry, x plus x. Okay, so WC is 2x. Well, now we know x is 2 radical 5. Now, remember, we talked about this first day. A distance doesn't make sense as a radical. So it is up to you to know what makes sense when. When I'm asking you to solve for a variable, that means you're going to leave it as 2 radical 5 because I want the exact answer. If you give me a decimal, you've rounded it and it's no longer exact. However, when you're giving a distance, it doesn't make logical sense for you to say, oh, the distance is 2 radical 5. Instead, you're going to find the equivalent. So 2 times 2 radical 5 gets you approximately 8.94. And in this case, we're looking at centimeters. Okay. Remember your approximates, remember your units, and all that. All right, so moving on to number 2. Number 2 is a little bit more going on. It says find the value of x, the length of AI, the length of WD, and the area of triangle RAH. Okay, so obviously first things first, you guys, there's nothing you can do until you solve for x. If you look, these triangles are congruent by angle, angle, A and I, and R and W. Again, not asking for it, but I always make a mental note. And then I'm going to say, okay, triangle, my first triangle, let's say, is ARH. Especially here, this helps me a lot because the triangles are not only overlapping, but one is turned on its side. So ARH has to be the same as triangle I, because they're both, the A and I are both your right angles. W, because those are both your marked congruent angles, R and W. And then D. Okay, so be careful here. This is one triangle, ARH. Okay, and this is another triangle right here. Okay, if it helps you guys, you can pull these apart here and here. Okay, and say, okay, this was triangle ARH. And if you look at the markings here, this is 3x. Now, this bottom side from A to H, well, this distance is 8 and this distance is 10, so its total is 18. Okay. Now, with your red triangle, this is your right angle at I, you have D, and then W is your congruent angle to R. This side is x plus 5. And this bottom side here, if you add those together, W to H is 10, H to I is x plus 5. So if you combine 10 and x plus 5, you get x plus 15. Okay, I like to separate them out like that. You don't have to, but then at least visually it's a little bit less to look at. Okay, so when we go to solve for x, let's see, we have 3x here, that's AR. According to the similarity statement, that's the same as IW. Okay, and that's the reason you really want to pay attention to it, because otherwise a lot of people say 3x and x plus 5 are the same, because they see them both as vertical angles. I'm sorry, vertical lines, not angles. And then AH has to be the same as ID, which is this right here. So when we go to set up our proportion, we're going to have 3x over x plus 15 equals 18 over x plus 5. Again, you guys, I set up my proportions so that I have my same triangles in the numerator and denominator. Mr. Lubers is going to set them up so his same triangles are in one fraction and then the other fraction. Either way, it's fine. If you set it up that way, then 18 and 3x should be in the same fraction, and x plus 15 and x plus 5 should be in the same fraction, obviously in the same spots. Now, you guys, when we go to cross multiply, we get 3x times x plus 5. And then we're going to get, it's going to go wonky on me. Okay, there we go. 18 times x plus 15. Okay, so we have to do some distributing here. So we end up with 3x squared plus 15x equals 18x plus 18 times 15, which is 270. Okay, so now, yay, we have quadratics. How exciting is that? We want to bring everything to one side because remember, in order to solve a quadratic, one side has to be 0. So my 3x squared is going to stay the same. If I subtract 18x over to get it out from the right side, that's going to get me a negative 3x. Sorry guys, you know how my computer feels about me. It hates me. Hold on. Hold the phone. There we go. Okay. Alright, so, like I was saying, 18 subtracted over gets you a negative 3x, and then you have minus 270, because it has nothing to combine with, equals 0. So, I'm going to look at this, and I'm going to take out a GCF of 3, and you're left with x squared minus x minus 90 equals 0. Okay, and then that's going to factor, so 3, we have x and x. Okay, if you think about your factors of 90, yes, you have 1 and 90, and 2 and 45. Obviously, you want them to be close together because you want them to add to negative 1. So I'm going to use negative 10 and positive 9 here. X times x is x squared. 9x minus 10x is negative 1x, and then negative 90. So if you set this all equal to 0, obviously 3 equals 0 doesn't get us anywhere. X minus 10 equals 0 means x could be 10, and x plus 9 equals 0 means x could be negative 9. Okay, now think contextually. Okay, one of our sides, let's just pick one of them, is 3x. Well, if x is negative 9, then that isn't going to work because you're going to get negative 27. So that's not an option, and the x value we're going to roll with is 10. Okay, so if x is 10, now we can go through and we can answer all the other questions that were asked of us. We need to find the length of AI. Okay, so I separated my picture, but let's go back to the original. Okay, AI is from here to here. It's the entire bottom. Well, this part right here is 8. This part right here is 10. And this part right here is x plus 5, but now we know that that's 10 plus 5, so it's 15. So in order to find AI, we can add 8 plus 10 plus 15, and then that's going to get you a distance of 33. Okay, so AI is a distance of 33, and this is in feet. Okay, the next thing we're asked to find is WD. Okay, so WD is this right here. Okay, now I don't have a pair, so it's not like we can set up a proportion, so we need to think, okay, I can't set up a proportion because I don't have a pair to compare it to. However, if you look at just this triangle, and this is one of the reasons I separated it out, it's a right triangle. So to find the sides of a right triangle, we can use the Pythagorean theorem. We know what x is, so we know that this side is now 25 because 10 plus 15 is 25, and we know that this side right here is going to end up being 15 when we also substitute in our 10 for x. So to find WD, we're going to do the Pythagorean theorem. Okay, we have 25 squared plus 15 squared equals, I'm just going to kind of work backwards, WD squared. Okay, or C squared, whatever makes you work better. Okay, so 25 squared plus 15 squared gets me 850, so WD squared is 850. Obviously, we're going to square root both sides there. And WD is going to be the square root of 850, which I'm not going to go through and reduce because I know in the end all I need is a distance. So I'm going to take my calculator and say, okay, if it's a distance, I'm going to do my decimal equivalent, which ends up being approximately, so let me get rid of that equal sign. Okay, it's going to be approximately 29.15. So that means this is 29.15 approximately feet. Okay. All right, the last thing we need to do is find the area of triangle RAH. Okay, area of a triangle. You guys, you've done that about a million times at this point. This is triangle RAH. Okay, so area of a triangle is 1/2 base times height, right? Maybe. Here we go again. All right, 1/2 base times height. All right, my base is 18. I already know that. The height of this triangle is 3x, but again, we already know what x is. So we can go ahead and say that that's 30. So if I have 1/2 times 18 times 30, I'm going to get 270. That's an area, and that's exact, so you don't need the approximate. 270 feet squared because it's an area. Okay. So you guys, obviously if you look at a problem like number 2, there's a lot of work to it, but if you just work through part by part, it's not difficult. We aren't asking you to do anything that is above and beyond what we haven't done already. So, like I said, the first thing, I always make that similarity statement. It makes life a little bit easier. I always use some sort of code to identify my similar sides, a circle, an underline, a star if there's a third one. And then both of these, and all of the problems today, your guiding force should be to find x first. Once you have x, you can go back and start substituting in. Maybe you need to use the Pythagorean theorem. Maybe you need to use an area formula. Maybe you need to find perimeter. Whatever the question is asking, Just remember, if you can solve for x first and go back and substitute it in, your life's going to be a lot easier. Okay, so for homework, you guys need to finish the next 4 problems. And whatever you don't finish in class, obviously you have to do over spring break. So buckle down, get it done, and then you don't need to worry about it.